Hello guys, in this video I'm going to show you how to reverse the linked list. Reverse linked list. So given a linked list, for example 1 2 3 4, right, there's 4 elements in the linked list, in this linked list. So the head is 1, the head of the linked list is 1, and the last node of the linked list will point to no. So our expected result is a reverse version, which is we will reverse it into 1 now is the last node, which point to no, then we choose 2 is now point to 1, 2 point to 1, 3 point to 2, and 4 point to 3, right? And now for the head node, right? So we have down here we have a node class represent one node in our linked list. A node includes a data, which is val property, and the next is a pointer that points to the next node. So for example, node 1, for the first node, the val is 1 and its next node is the next 2, either node 2, right? Node 1 keep on pointer to node 2. So how we can solve this problem? Let's move it down. For this kind of problem, you can try to iterate to the linked list to see how we can somehow iterate. But the problem, the requirement here is that we not allowed to use extra space. So it means we're gonna reverse in place, right? So I'm thinking about doing some changing pointer swapping, right? I'm thinking of the most intuitive way is to just probably we want to iterate to for each node, right? We want to probably change the pointer now 1 pointer 2, so we want to point 2 back to 1, right? So we can do that for each node, but there may be some other concerns that we need to take care of. Let's start with 1, right? Probably we want to keep a current pointer, right? Current pointer, and so for each pointer, for example, we are sitting, let's imagine we are at the middle of the linked list. Probably want to for each node we want to point back to the previous node, right? So how about keeping a previous node, which is initially is null, so that when we start with 1 it will point to null, right? Let's start with no. So current is 1. We're standing at 1. So probably we want to point back 1 to null, right? Point back 1 current node to previous, which is null in this case. But one very important thing here is that when we point 1 to null, we accidentally lose the connection to 2, right? We point backward to previous. So probably want to, before changing the next pointer to the previous, we probably want to save the next pointer, current next pointer, right? So we set current next pointer, we point the current next up current to null. Then we're done with the current node, right? So probably we want to move to the next node, right? We want to move to the next node, which is what we have already saved. But we probably, before moving from 1 to 2, we probably want to update the previous, because our goal at each node is to change the next pointer of current node to the previous node. So probably we want to update the previous to 1 first. Then we move to 2, right? So now we are 2. The same logic as the first node. We want to point next up 2 to 1, but we will lose the pointer to 3, right? So we must somehow save 3, right? We save 3 first. Then we point backward, right? Like this. We point to previous, which is 1, right? So now we're done with the node 2. Same logic, we need to update previous to current, which is 2, so that we can move the current node to the next node. Our goal is again point to previous, which is 2, but before doing that, we need to save the next node. We change the pointer here, right? So we're done with 3. We update the previous to 3 before moving current to 4. So our goal is to change this next pointer backward to 3, right? Sorry, wait a minute. Before change the pointer of 4, we probably want to save the next node, right? It's null in this case. We change the pointer to previous node, which is 2. We accidentally lose the next node pointer. So now we're done at 4. We move current pointer to the next node, which is no value. So probably as you can see, our linked list is already reversed. So probably when the current node saying no, we want to we're done. We just exit the loop, right? So as you can see, we probably want a current pointer and previous pointer. So we set previous pointer initially is no. So we want to run into loop as long as the current pointer, which is current initially points to head, right? As long as we have the current pointer, we want to run into the loop. But when the current pointer is no, we want to exit because we're done reversing the linked list. So for each current pointer, we want to first, our goal is to point the current pointer. We want to change the next pointer of current pointer to previous, right? But by doing this, we accidentally lose the connection to the next node. So probably before doing that, I'm gonna store its current of next, right? Next of current next, for example. Let's say current of next. Okay. We point the current of next to previous, right? So it means we're done with the current node. We want to move to next node, right? To next node. So in order to move the next, we need to update the previous node, right? The previous node will now equal to current node, and the current node, which is the current node, is what we already store in the current next, right? Current node is current next. We don't want to lose this one, so we store it so that later we can, retrieve it back and assign it to the kernel so that we can start a new iteration with the next node, right? So our goals at each node, at each current node, is to change the next pointer backward to the previous node. Simple as that. So as we exit this one, do we need to return anything? Let's see the test. No, we don't have to return anything. So probably I want to run the test now. Yes. Number 6 and number 1. Let's see. Awesome. So that's it for this video. Thank you for watching. See you in the next video.